Hello, students, and welcome to today's Friday Happy Hour. Today's going to be the last session for this semester, and we're going to be going over the final exam review, which most likely is going to be next week. Okay, so these are the topics that I'm going to cover today: linear equations, quadratic equations, applications on linear and quadratic functions, exponential functions, application on exponential functions, solving exponential problems, financial applications, solving systems of equations, matrices, sets, and Venn diagrams, probabilities, and permutations and combination. It's the material that we were exposed throughout the semester. I believe not every instructor will give you all this information for the exam, but I'm trying to cover as much as I can. That way, some of this material will be on your exam. Okay, so let's begin with linear equations. Number one states find the equation of the line passing through the the 2 points, which is negative 2, 5 and negative 4, 6. So what's my solution? My solution is that we have to find the equation in slope-intercept form, which is y equals to mx plus b. So I need to find my m, which is the slope, and the y, and the b, which is the y-intercept. Here's a formula for my slope. My slope, which is m, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the y-intercept is b equals to y minus mx. Okay, now, so for the formula to be performed, we need to call a point 1 and the other point 2. It doesn't matter which point you want to call point 1 or point 2. But the way I explain it is the first point is point 1 and the second point is point 2. Right? So we have negative 2, 5, which is point 1, and negative 4, 6, which is point 2. So you notice x sub 1 is negative 2 and y sub 1 is 5. X sub 2 is negative 4 and y sub 2 is 6. So we're going to put them into the formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it's going to give us negative 1/2. Okay. Now, I'm going to choose one point. It doesn't matter what point you use. I believe here I'm going to use the first point, negative 2 and 5. Okay, so this is my formula. I'm going to find the b is y minus mx. The y is equal to 5, right, from the point, and the x is negative 2. And my slope is negative 1/2. So let's plug everything in, right? There's my y, there's my m, my slope, and there's my x. So the answer is going to be 4. So b is 4. Because negative 1/2 times negative 2 will give us a positive 1. And 5 minus 1 will give us a 4. So here's my equation. Y equals to negative 1/2 x plus 4. That's the equation that we're looking for. Now, this is number 2. This is called find the difference quotient. And here's the formula. So solution, right? So we have to first find f of x plus h, which is the first part of the equation. Which means I'm going to go to my original function, and I'm going to plug in x plus h for every x. You see, so this is my x squared, so I'm going to plug in x plus h for the x, and also minus for the x, I'm going to plug in x plus h again. Then here we have to multiply the binomial, which is x plus h squared is x plus h times x plus h, which will give you x squared because x times x is x squared, and x times h is xh, h times x is xh, and h times h is h squared. The two in the middle, the two middle terms, you can actually combine them because they're considered like terms. So then I'm going to plug that in for the x plus h squared minus x plus h plus 4. Now I need to distribute the negative. There's like a negative 1 there, right? But you don't see it, but there's like a negative 1 there. So I'm going to bring down the x squared plus 2xh plus h squared. And then negative times a positive will give you a negative x. Negative times a positive h will give me a negative h. And we'll just bring down the 4. So now I'm going to do the f of x plus h, right? Which is all this is my f of x plus h minus f of x, which is the original function. There's my f of x plus h minus my f of x, which is the original function, as I said earlier. Now, with a minus, all these signs are going to switch, or you multiply negative times a positive will give you a negative. Negative times a negative will give you a positive x. Negative times a positive 4 will give us a negative 4. Here's like a hint that I tell my students. Every term that doesn't have an h has to be eliminated, okay? For example, does x squared have an h? The term knows, right? So somewhere there's going to be a negative x squared, and here it is, right? So that'll be 0. Does this term have an h? Yes, so that's going to stay. The h squared has an h, so it's going to stay. The negative x, does it have an h? No, so that term also must be eliminated. And here it's over here with the x. The h has an h, so it stays, that term, and the 4 doesn't have an h, so that one has to also be eliminated. So we have to find a negative 4x, and here it is at the end. So the 4 will be eliminated with a negative 4. So what's left? By 2xh plus h squared minus h. Now comes, now I'm going to factor out an h. And now comes step 3, right? Which is a whole difference quotient. So the 2h's will cancel, or h divided by h will give us 1, right? So that's my result. So this is my result that we're looking for. And this type of problems, you will see them again if you're taking the next course, which is a 1325. For the students who are majoring in math, I mean not math, in business or accounting, you're going to see this again. Okay, like in more detail. There's a whole chapter on this. Okay, so anyway, let's move on to number 3. Number 3 is an applications problems dealing with linear functions. The manufacturer suggested the retail price, which is called the MSRP for a base model 2016 Toyota Prius, is $25,035. And it is expected to be worth $14,115 in 4 years. So find the linear depreciation function for this car. That's part A. And part B, you can estimate the value of the car 5 years from now. And part C, at what rate is the car depreciating, right? Because the price is going down every year. So what's my solution here? I need to find 2 points with the given information. According here, guys, this problem here, right? This is a brand new car. So before it leaves a lot, no time has passed. So we're going to get the first point is going to be 0, 25,035. That's my point 1. And then, right, and then in 4 years, which x will be 4, right, the car is worth 14,115. So we get the other point, which will be 4 and 14,115. I found my 2 points. Now we're going to do the same procedure as we did, I believe, in slide number 1, which was the problem number 1, where they give you 2 points and you have to find the equation of the line. That's what we're looking for here for part A. So we need to find the slope and the y-intercept. Okay, so here, guys, since this is point 1, right, it's going to be y sub 2, which is 14,115 minus y sub 1, which is 25,035. And x sub 2, which is 4, minus x sub 1, which is 0. This will give us negative 10,920 over 4, which will be negative $2,730. So every year, the car is going down by $2,730. So this is my slope. Now I need to find my b. b is equal to y minus mx. So you always use the point that's easier for you. In my opinion, the first one is easier because it has a 0. So my y is 25,035, my x is 0, and my slope is negative 2,730. So let's plug it in. Right, here's my y, minus my slope, my m, times the x. So b is equal to 25,035. Now here's my function. There's my slope, there's my b, plug him in, and this is the equation that we're looking for. This is part A. Okay. Okay, now part B. Estimate the value of the car in 5 years from now. So 5 years, so we're going to be looking for f of 5, right? We're trying to find f of 5, which means I'm going to plug in 5 for every x on the equation, which will be negative 2,730 times 5 plus 25,035. So the answer should be, the answer is 11,385. So in 5 years from now, the car is worth 11,385. Now part C. At what rate is a car depreciating? In other words, what is the slope? But since the word depreciating is already there, we don't have to put the negative sign. So the answer will just be $2,730 per year. That's how much the car is depreciating every year. Okay. I believe in WebAssign, in my math lab, if you put a negative, the answer is wrong because it already means that it's depreciating, right? Without putting the negative. So this is the answer that you should put on your homework for the My Math Lab. Okay, now number 4 is going to be, they're going to give you a function, right? It's in the form ax squared plus bx plus c. You have to find the vertex, the x-symmetry, the y-intercept, and the x-intercept of the function. Right, so that is in this form, right? The ax squared plus bx plus c. So here's how you find the vertex. This is a formula for the vertex. Negative b over 2a is the x value. And then for the y value, you plug in whatever you got on the x value, you plug it into the original to find the y value. Now the x-symmetry is also, once you get the vertex, it's the x part of the vertex, and you have to put x equals to negative b over 2a. So this is the x-symmetry. Now the y-intercept is 0c. Whatever the c is, the constant term, that's your y-intercept. So without doing no work, you guys should be able to know what the y-intercept is every time, because here is going to be the 9. Okay? And the x-intercept, you got to factor or use a quadratic formula. So let's start with finding the vertex. We know that my a is equal to 1 and my b is 10. So plug it into the formula. So be negative 10 over 2 times 1, right? Because it's negative b and my b is 10. That's why we plug in the 10 for b. So the answer will be negative 5. So this is my x part of the vertex. Now for the y part, I'm going to plug the negative 5 back to the original. Or in other words, I'm going to be finding f of negative 5, which means I'm going to plug in negative 5 for every x, which is on the space, and also here on this space here, because we're plugging in negative 5 for the x's on the function. That will give us 25 plus 50 plus 9. The answer will be negative 16. So this is my vertex, negative 5, negative 16. Now, after you find the vertex, right, the x-symmetry is also the x part of the vertex. So what was the x part of the vertex? X equals to negative 5. Again, the y-intercept is equal to the c. So here, what I'm going to do, I'm going to put the c will be 0, 9. C is 9, so the answer will be 0, 9. Okay. Now, the x-intercept, we got to factor. So we have to let the function equal to 0. So to factor, right, it's going to be x plus 9 and x plus 1. I believe I did a PowerPoint on factoring. I believe it was week 3. If you guys don't know how to factor, try to look over that PowerPoint that I went over in week 3, and perhaps it can give you an idea how to factor. But these are the factors of the trinomial x squared plus 10x plus 9 is equal to x plus 9 and x plus 1. So then we let both equal to 0. Right, so x equals to negative 9 and x equals to negative 1. So these are my x-intercepts. So I found what they were looking for. Okay. And I believe also on your homework, you'll probably need to graph it, or the instructor might ask you to graph it also. I didn't graph it here, but to graph it, all you do is plot all those points and graph it. Okay? I mean, just go, the parabola should go through all those points. Now, what happens if the function is in this form, in the x plus 3 squared minus 16? I believe in some books, this is called the vertex form. But in this book, they just call it the rule. The rule x plus 3 squared minus 16. So in other words, this is a function, right? It's in the form a times x minus h squared plus k. Hey guys, for this particular form, there's two things that are obvious. The vertex is obvious, is visual, and also the axial symmetry is also visual. So without doing anything, you guys should be able to know what the vertex is and what the axial symmetry is. Okay? For example, right? For example, right? This is my h and this is my k, right? From the formula. But if you notice, on the formula, if it's negative here, the h is positive here, which is the x part of the vertex. So if it's positive, it's going to be the opposite. So my vertex will be negative 3, negative 16. That's your vertex, and that should be visual. So students should know what the vertex is without actually doing no work, just by observing the function. Now the axial symmetry is the x part of the vertex, so it's going to be x equals to negative 3. And that's your vertex, so this is my axial symmetry, x equals negative 3. Now to find the y and x intercepts, you have to do a little bit of work. So for the y-intercept, right, here's a rule for the y-intercept. You're going to let x equal 0 and solve for y. Right, so g of x is the same thing as y. So if we let x equal 0, that means that this will be 0 there. So what's 0 plus 3? The answer will be 3. 3 squared minus 16. 3 squared is equal to 9. 9 minus 16 is equal to negative 7. So my y-intercept is 0, negative 7. Now for the x-intercept, right, you're going to let y equals to 0. So it's going to be x plus 3 squared minus 16 equals 0. So I have to solve for x, all right? But you have to take the proper steps in mathematics. The first step is try to isolate the term that has an x, which is x plus 3 squared. So the first thing, I'm going to add 16 to both sides. Right, so after I do that step, I have 16 equals to parentheses x plus 3 close parentheses squared. Now I'm going to take the square root of both sides. Right, so if I just put the right side, I put it on the left, and the left side I put it on the right, because it's always x equals to something. So here, guys, if we take the square root of here, this will cancel the square root. The square will cancel the square root, so that'll be x plus 3 equals the square root of 16 is 4, so it'll be plus or minus 4. We subtract 3 from both sides, so we have x equals to negative 3 plus or minus 4. So it'll be negative 3 plus 4 and negative 3 minus 4. So the answer x will be 1 and x will be negative 7. So these are my x-intercepts. And again, if you need to graph it, all you do is plot all those points, and the graph should go through all those points. Okay. Now, how do you apply quadratic equations in real life situation? This is number 6, explains that situation, okay? So for example, it says the revenue for McDonald's Corporation in billions of dollars for the years 2010 to 2015 can be approximated by the quadratic function r of x equals to negative 1/2 x squared plus 13x minus 57, where x equals 10 corresponds to the year 2010. So for A part, they're asking to find the vertex. And then for B, in what year during this period was the revenue at a maximum? And for C, what was the maximum revenue to the nearest billions of dollars? So once you find part A, you also found part B, B and C, because B will be the x part of the vertex, and C will be the y part of the vertex. Okay, let me show you how it's done. So again, this is the formula for the vertex. So I have to know what the A and the B are. So my A is negative 0.5 or negative 1/2, and my B is 13. So let's plug it into the formula. So I'm going to plug in 13 for the B is, and I'm going to plug negative 0.5 for the A is. So the answer will be 13. Right? So then, for the Y part, we find R of 13, because this is a revenue function. So we plug in 13 for every X, right? On the X squared and the X here for the 13X, the answer should be 27.5. So this is my vertex. My vertex is 13, 27.5. Now for B part, in what year during this period was the revenue at a maximum? Which means, what's the X part of the vertex? Okay, I jumped again a little bit. We're looking for the X part of the vertex, so the answer will be, if 2010 is X equals 10, so then 13 will be 2013. That's the answer for B part. And for C part, what was the maximum revenue to the nearest billions of dollars? So then, right, this will be the Y part of the vertex. So the answer was 27.5, but I want you to run down to the nearest billion, so it'll be 28 billion. So these are my answers, guys. And again, this is not that complicated. Once you find the vertex, you also found parts B and C, which is in what year during this period was the revenue the maximum, and what was the maximum revenue to the nearest billions of dollars. Okay, so that's how we do number 6. Now number 7, we're solving the exponential equation. Okay, they give you 9x equals to 27. Because here, guys, you have to have the same base. Or you can take the element base, at both sides. But here, guys, let's do it with putting them both sides of the equation in the same base. So we first start by doing 9 squared, right? 9 squared gives me 81, which is not equal to 27. That means that we have to find the same base for both the left and the right side. Find a common base between 9 and 27, and the common base is going to be 3, because 9 is equal to 3 squared, and 27 equals to 3 cubed. The 9 becomes 3 squared, and the 27 becomes 3 to the third power, or 3 cubed. Now we apply the power rule. When you have a power to a power, we multiply the powers. So this will be 3. 2 times x will give us 2x. And then the right side will just be 3 to the third power. When you have the same base, then you let the exponents equal to each other. And all we do is solve for x. So we divide both sides by 2, so x equals to 3 over 2. That's my answer for number 7. But you can always check your work. I'm going to plug in 3/2 for the x's. If you put that in the calculator, guys, it's going to give you 27. So 27 equals to 27, so I know it's true. It's correct. Okay, now how do you apply exponential functions in real life? Here's a good example. Number 8. The assets in billions of dollars for a Prudential Financial Incorporated can be approximated by the function AX equals to 315 e to the 0.056x, where x equals 7 corresponds to the year 2007. It says find the assets for the following years, the year 2000 and the year 2012. So solution, if x equals 7 corresponds to the year 2007, then x equals 0 should correspond to the year 2000, and x equals 12 should correspond to the year 2012. So for A part, all we're going to do is plug in 0 for the x, or we're going to evaluate A of 0, which means we're going to plug in 0 for the x's. That's going to give us 315. Since the answer was in billions, we have to put billion, right? So it's 315 billion, because it says in billions of dollars. So this is good to know that 315 is the initial value because time is 0. Right? No time has passed. So this is your initial value, the 315. Okay, now for B part. Right? We're going to find A of 12, which means I'm going to plug in 12 for the X. We put in the calculator, guys. So we're going to get 616.817. So it's going to be $616.8 billion. That's the approximate. Okay, now let me go back real quick. Hey guys, that's why I put here. Good to know that 315 is the initial value because time is 0. We're going to apply this concept in the next problem. Hey guys, this is an actual problem that I came up with, and that was right before COVID. I believe I told my students that when the cases were increasing, we decided to actually come up with a formula to see how many people will be infected if there was no intervention. And this because I like to relate mathematics to real life situations, and this was a perfect example right before we went to spring break in the year 2000. Right, that was when the coronavirus was has started here in the United States. So anyway, here's number 9. It says a deadly virus has infected the world. At the end of January, there were 2 cases, and by the end of April, the cases had grown to 128. I believe this was actually, I got the data from the news that there were 2 cases, I believe, in Washington, right? And then like in April, there were 128 cases, I think here in the U.S. So with those numbers, we can approximate how many people will be infected at a specific month. Okay, so this is how we relate it to real life. So the solution is the first thing we got to do is find a model in the form f of t equals to y naught b to the t power, with t equals 0 corresponds to the end of the month of January. Because it's saying here at the end of January there were 2 cases, so it's going to be 0, 2, right? So y naught is, so we need to find my y naught and my b. Y naught is the amount present at time when t equals 0. That's what I explained in the previous slide where I said this is good to know. So my initial value is going to be 2, right? Because 0, 2, right, when we started, right, there were 2 cases. That's why the point comes from 0, 2. Now, it says here on the problem, by the end of April, the cases had grown to 128, right? So t equals 1 corresponds to the end of February. Because t equals 0 corresponds to the end of January. That's why that was when the 2 people were infected. So t equals 1 corresponds to the end of February, t equals 2 to the end of March, and t equals 3 to the end of April. So 3 months later, right, after the initial people were infected, 3 months later, there were 128 cases. So I'm going to use this information to come up with a formula. Use what we know to find B. So we know that A or my y naught is equal to 2, right? And then from the other point, we know that in 3 months later there was 128. So right, so 128 equals to 2b to the 3rd power because the 3 is my time. So you see that's why the 3 replaces a t. Now I have to solve for b. The first thing we're going to do is divide both sides by 2. If we do that, we're going to get 64 equals to b to the 3rd power. Now we have to isolate b. So I'm going to raise it to the 1/3 power. So we raise both to the 1/3 power. So remember here we apply the exponent rule. When you have an exponent to an exponent, you multiply the powers. That way, this will cancel the 3 will cancel with the 1/3. It'll be 1. And 64 to the 1/3 power will give you 4. So we know that b is equal to 4. So I found my y naught and I found my b. So plug into the formula. There's my y naught, there's my b. So this is a formula that we're looking for. Okay. So now, for part B, right, it says by the end of the year, which is the end of December. So from the end of January to the end of December is going to be 11 months. So we find f of 11. So we plug in 11 for the t, and we got, let's see, 8,288,608 people were infected by the end of the year. But I believe it wasn't that many at that time because there were interventions, like, for example, social distance, right, which was 6 feet apart. And also they emphasized by wearing masks. So all that kind of prevented for this many people, which is over 8 million, to be infected. This was an approximation that I told my students if there was no intervention. This will be like an accurate estimate of how many people would be infected if there was no interventions. So it's good to know how does math relate to real life situations. This way, because we should know that math is with us, like it or not. It's in our daily use. So this was a very good example of how math is used in real life. Okay, now this is number 10. Number 10 is, I believe it's from the finance chapter 5. It says Gabriel invested his summer earnings of $3,000 in a savings account for college. The account pays 1.5 simple interest. What will be the value of the account after 2 years? And how much interest did he earn? So right away, guys, it says simple interest. So for simple interest, this is a formula for simple interest. Okay. And I believe this was a PowerPoint that I presented, I think, in week 6 or week 5, something like that. But the AV stands for future value, the PV stands for present value, the R stands for interest rate, and the T stands for time. So for the word problem, we have to extract the info and see what we're looking for. Here, guys, what we're looking for is what will be the value of the account after 2 years. So after 2 years means we're looking for the future value, right? So in other words, so if we're looking for the future value, the 3,000 has to be your present value because that's how much he invested at the present time. My R, which is the interest rate, is very easy to observe. It's the number that has the percent symbol. So it's going to be 1.5%, but you have to convert it to a decimal. So you divide 1.5 by 100, or you move the decimal place 2 places to the left and drop the symbol. So 1.5% is equivalent in decimal to 0.015. And the time is 2, right? 2 years. All we do is plug everything into the formula, just the way it is, and put it in the calculator. The answer is 3,090. Now to find how much interest did he earn, right? We subtract the present value from the future value. So it'll be 3,090 minus 3,000. The answer is 90. So this is how much interest Gabriel earned. So this is the answer after the account, right? There was 3,090. After 2 years, there's the answer for the first part. And for the second part, interest earned was $90. These are the solutions to this particular problem. Number 11. You deposit $9,000 in an account at your bank that pays 2.5 interest semi-annually. How much money will be in your account after 10 years? And how much interest did you earn? Right away, guys, this type of problem, we should know is going to be a compound interest problem. Why? Because compound is compounded semi-annually, which means twice a year. So this is a formula that you'll be using. But in my opinion, it's easier to use the second one because my I is equal to R divided by M, and my N is equal to M times T. You see, this is easier to input in the calculator. So there's 7 things that you gotta account for. The FV, the PV, the R, the M, the T, and the I is equal to R divided by M, and the N is equal to M times T. So here, guys, they said that you deposit, right? So you deposit right now $9,000. So we're looking for the future value. So 9,000 goes for the PV, present value. The interest rate will be 2.5%, right? Converted to a decimal, it'll be 0.025. The M stands for compound, and semi-annually means twice a year. The time is 10 years, so the time is 10. Now, what's the I? The I is R, which is 0.025 divided by 2, which will give us 0.0125. And the N is equal to M times T, which will be the 2 times the 10, which will give us 20. So let's plug into the calculator, right? So this is my present value. That's my the 1 plus my I to the nth power. You should get something like 11,538.33509, rounded off to the nearest penny, which will be 11,538 and 34 cents. Okay, after 10 years. So how much did you earn? Interest that you earn? Right, so we're going to subtract the money that you deposit minus the value after 10 years. So it's going to be 11,538 and 34 cents minus the initial value that you invested, the 9,000. You're going to get something like a little bit over $2,500, which would be $2,538.34. That's how much money you earned extra. Okay. Now this is number 12. I believe this is solving linear systems of equations. Solve by graphing. Right, so I'm going to graph both equations. My slope, to graph, you need to know what the slope is and what the y-intercept is. My b is the y-intercept, and my slope is going to be the rise over the run. So here it means that the b or the y-intercept is your starting point. So I'm going to start at 0, -6, which will be right about here. Then I'm going to go up 3, be positive, 3 up, and 1 to the right. So I'm going to go 3 up from the point, from the y-intercept, 1, 2, 3, and 1 to the right. So the point should be about right there. And then all we do is connect the points. That's my line for equation number 1. For equation number 2, you have to put it in the slope-intercept form, which is y equals to mx plus b. So we have to isolate the y. So first we add 5x to both sides. So after I execute that problem, the adding 5x to both sides, it's going to give us -2y equals to 5x minus 10. Then I divide both sides by -2. So it's going to give us y equals to -5/2 x plus 5, because -10 divided by -2 will give us a 5. Now I got my slope is -5/2, and my y-intercept is 5, which will be 0, 5. So here, this is my starting point. My b is my starting point. So we're going to start at 0, 5, which is up here. Then the -5/2 means that I'm going to go down 5. 1, 2, 3, 4, 5, and 2 to the right. 1, 2. Then my starting point. Right, so we connect them. So there's my answer. Where do the two lines intersect? At the point 2, 0. That's my solution. Okay, now this one, they want you to solve it by using the elimination method. Okay, for this one, you have to put it in proper form, right? They both have to be in the form ax plus by equals c. Equation 1 is not in proper form. So I need to rewrite it in proper form, which means that I'm going to add 2y to both sides. Okay, so we're going to get x plus 2y equals to 19. Now they're both in proper form. So here, you either want to eliminate the x's or eliminate the y's. I always get asked from students, hey, mister, what should we do? And I tell them, you have to know the concept here. You have to eliminate either the x's or the y's. It's up to you what you want to eliminate. I was telling my opinion. In my opinion, it's easier to eliminate the x's, right? Like I said here, whatever is easier for you. Because if I eliminate the x's, I need to multiply only equation 1 by -4. Why? Because -4 times x will give me -4x, and then when I add it to the second equation, the -4x and the 4x will be eliminated. Okay, but I have to use proper math procedures, which I need to multiply -4 times every term. -4 times x will give us -4x. -4 times 2y will give us -8y. And -4 times 19 will give us -76. So equation 2, we just bring it over. Right, now we do the operation. So -4x plus 4x will give me a 0x. -8 minus 3 will give me -11y. And on the right side will give us a -77. Now we divide both sides by -11. And the result is y equals to 7. Once you have the y value, right, you need to find the x value because the answer is an ordered pair, is a point. It has an x value and also a y value. So I need to go back and plug in 7 on either equation 1 or 2, whatever is easier for you to find the x. In my opinion, guys, it's easier to go to the original equation number 1 here, because if we're looking for x, the x is already isolated. So I'm going to plug in -7 for the y here on the right, right? So it'll be -2 times 7 plus 19. This is going to give us -14 plus 19, so the answer is 5. So what's my answer? The answer is 5, 7. That's my point. Okay, now how do you apply this type of problem in a real-life situation? And I'm going to show you an example here. It says, number 14, a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? So this is the plan. I need to find two equations. So I'm going to keep seats with seats and money with money. What does that mean? It means that I'm going to let x equal to adult seats and y equal to children seats. And there were a total of 200 seats. So my first equation will be x plus y equals to 200. Now comes money with money. If I let x equals to adults, right? And the adult tickets are $8, so it's going to be 8x. In a similar fashion, the children's tickets, right, is represented by y, so it's going to give us 5y. And then what was the total income or the total revenue was 1,435. So 1,435 goes there. So my second equation will be 8x plus 5y equals to 1,435. So we found both equations. Now we can solve it by using the elimination method. So I'm going to get rid of the x's on equation 1. So I need to multiply by -8. We multiply -8 times every term. So it should give us -8x minus 8y equals to -1,600. And equation 2, we just bring it over. So the x's will cancel, right? It'll be 0. But -8y plus 5y will give us a -3. And -1,600 plus 1,435 will give us -165. We divide both sides by -3. We get x equals to 50, y equals to 55. Now you can go there either back to equations 1 or 2. Equation 1 is much, much easier. So I'm going to plug in 55 for y. We subtract 55 from both sides. And that'll be my answer for x. So the x is 145 and the y is 55, right? But x represents adult tickets. So here's my answer. So 145 adults and 55 children were in the theater. Okay, so my answer will be 145 adults and 55 children. This is called like a larger system of linear equations, which means you can have three variables, right, and 3 equations. So for this one, I tell my students that this is like the plan or the strategy. I'm going to get equations 1 and 2 and get rid of the x's. And also the same thing with 1 and 3. So this is equation 1 and 2, right? So I'm going to eliminate the x's. So equation 1, I need to multiply by negative 2. So then I'm going to multiply negative 2 times every term. So I get negative 2x plus 6y minus 4z equals 0. And equation 2, we just slide it over. So in this procedure, the x's get eliminated. So we're going to get 4y minus 3z equals 3. That's like my new equation 2. Now I repeat the process with equations 1 and 3. Here I'm going to get rid of the x's, so I'm going to multiply equation 1 by negative 3. So I have to execute this step. I should get negative 3x plus 9y minus 6z equals to 0 because I multiplied negative 3 times x, negative 3 times negative 3y, and negative 3 times 2z, and this is my result. So equation 3, we'll just bring it over. So the x's, right, will be eliminated. So 9y plus y will give us 10y. Negative 6z minus z will give us negative 7z, and 0 plus 7 will give us 7. So this is my new equation 3. Now I'm going to get the new equations 2 and 3 and eliminate the y's. Which means here, this is the hardest it gets because here I have to multiply both equations by a number. So like I tell my students, just multiply the equation 1 because they're both positive, right? So equation 1 you multiply by negative 10, and equation 2 you multiply by 4. This will guarantee that it will eliminate the y's. So we multiply negative 10 times every term in equation 2. It should give us negative 40y plus 30z equals to negative 30. And that was a result of multiplying negative 10 times 4y, negative 10 times negative 3z, and negative 10 times 3. This will be my result. In the same fashion, we multiply 4 times every term. So it's going to give us 40y minus 28z equals to 28. The y's were eliminated, so we're going to get 2z equals to negative 2. So we divide both sides by negative 2. So we got z equals to negative 1. Now I got 3. Now I'm going to back substitute. In other words, I'm going to go back to either equation 3 or 2 and plug in negative 1 for z. Here I chose the first equation, the new equation 2, and the original equation 1. So I'm going to go back and plug in negative 1 for z on equation 2. Right, so that's my z, negative 1. So we have 4y plus 3 equals 3. We subtract 3 to both sides. So it's going to give us 0. 4y equals 0. We divide both sides by 4. So y equals to 0. I already found my z and my y. Now I go back to equation 1. I know that y equals 0 and z equals negative 1. So I'm going to plug him into equation 1. So y is 0 and z is negative 1. So it's going to give us x minus 2 equals 0. We add 2 to both sides. So x equals 2. So this is my solution. 2, 0, negative 1. Now we're going to be multiplying matrix. Okay, I believe we got 10 minutes. Hey guys, I'm going to go a little bit over the time because I want to cover everything that I mentioned at the beginning. Okay, so let's try number 16, A, B, and C. So first I need to multiply negative 4 times A, so it'll be negative 4 times every element in matrix A. So I multiply negative 4 times negative 2, negative 4 times 0, and negative 4 times 5, and negative 4 times 3. So it's going to give us 8, 0, negative 20, negative 12. Then I'm going to do the same thing, multiplying 5 times matrix B. Right, so B 5 times 0, 5 times 2, 5 times 4, and 5 times negative 6. So the result will be 0, 10, 20, negative 30. Now for part C, I'm going to combine the negative 4A plus 5B. So this is my negative 4A, right? It was here in blue. It was 8, 0, negative 20, negative 12, plus 5b, right? It's going to be 0, 10, 20, negative 30. Remember that to add two matrices, you have to have the same size, and these are the same size. This is a 2 by 2 matrix. There's also a 2 by 2 matrix. So it's going to be 8 plus 0, 0 plus 10, negative 20 plus 20, and 12 plus negative 30. You're going to give us 8, 10, 0, and negative 42. That's my result. Okay, now, number 17. Let's multiply matrix B times A. Matrix B times A, right? So there has to be like a certain order for you to be able to multiply it. You see, the two numbers must match in order for it to be done. If the two numbers did not match, then it's not possible to multiply the matrix if the two numbers in the middle don't match. Since we have a match, then the answer is going to be a 2 by 3, the outer numbers. Here's how we do it. Okay, so I'm going to get matrix B, right? Then I'm going to put matrix A. So I'm going to multiply the first row times every column. So we start with 2 and 4. So it'll be 1 times 2 is 2, right? And 0 times 4 will give us 0. So the answer will just be 2. So 2 goes on the first lot. Now, we're going to multiply the first row times the second column. Right, so it'll be 1 times 0. That's why I'm going to put them in color code. 1 times 0, 0 times negative 2. The answer will be 0 plus 0. The answer is 0, so the 0 goes on the first row, second column. Now comes step 3. So I'm going to multiply the 1, 0 times the third column. So 1 times 5 plus 0 times negative 3. The answer will just be 5. So the 5 goes in the first row, third column. Since we're done with all the columns, now we're going to do the second row times every column. See, now we're doing the second row times column number 1. So 4 times 2, negative 2 times 4. That will give us 8 plus negative 8, or 8 minus 8. The answer is 0, so the 0 goes on the second row, first column. Now comes step 5. So we're going to multiply the second row times the second column. That's why it's in red. So 4 times 0 plus negative 2 times negative 2, which will give us positive 4. So the answer that goes on the second row, second column will be 4. Now comes the last step. I'm going to multiply the second row times the last column. So 4 times 5 plus negative 2 times negative 3. The answer will be 26. So this is my solution. 205, 04, 26. That's how you work. That's how you multiply matrices. Now we're doing sets. I believe this is from chapters 8 and 9, the last two chapters. 18, right? They give you this is the universal set, which is A, B, C, D, E, 1, 2, 3, 4, 5. And set X has the elements A, B, 1, 2, 3. Set Y has the elements B, D, 1, 3, 5. And set Z has the elements B, 2, 3. Okay, so here's what. So since we have to find the complement of X, the complement of Y, let's do them here. Hey guys, the complement of X, which means not X. So we go to the original, to my universal set. So not X means not A, not B, not 1, not 2, not 3, because not these right here, so whatever's left. So that means my C is left, my D is left, my E, my 4, and the 5. So not X, or the complement of X, the answer will be C. The elements will be C, D, E, 4, 5. That's my set Y, right? So the not Y will be not B, not D, not 1, not 3, not 5. So not B, not D, not 1, not 3, not 5. So what's left is A, C, E, 2, 4. We got my ZZ. So here we go. So A intersects Y, which means A and Y. That means what do those two sets have in common? Right, so let's go here to the right. They have in common a B, a 1, and a 3. That's your result. Okay, now X union Y or X or Y. That what that stands for. That stands for or union. Like I tell my students, since X is first, I'm going to put everything in X, which is A, B, 1, 2, 3. Then you're going to go to Y. If the element is already there in the set, you don't write it again. Okay, let's go to Y. Is a B there already? Yes, you don't write it again. Is a D there? No, so let's put the D. Is a 1 there? Yes, it is, so we don't put it again. Is a 2 there? No, so yeah, the two's already here, right? So we don't, no, I mean the 3. Is the 3 already there? Yes, so we don't write it again. How about the 5? No, so we put the 5. So that's my solution. And you repeat, you put them all down, but you don't repeat them. Okay, now the answer for C is not X, right? But the back of the book or my math lab, they put them in order. But in reality, if you put this as the answer, it's not wrong because these are equal sets. They have the same exact elements. Now the complement of C, right? For C, the complement of X, we already did it here, so this is my answer: C, D, E, 4, 5. Okay, now for the complement of X and the complement of Y, it means what do these two sets have in common? So they're already here on the right. So they have in common a C, an E, right? In common an E, and a 4. That'll be my solution. Okay. Now we're doing E, the complement of X and Z, which means what do these two sets have in common? So they're here on the right. So what does not X and Z have in common? If you notice, there's nothing in common because C is not here in Z, nor D, nor E. They don't have that in common, nor 4 or 5. So the answer will be an empty set. Okay, these two means empty sets, those two symbols. Now let's do F. F, right? So first we have to do what's in parentheses. What does Y and Z have in common? So let's go to Y and Z. They have in common a B and a 3. Right? Now, the set of Y intersects Z is B3. Now we have X union B3. So again, we start out with what's in X. It's going to be A, B, 1, 2, 3. Now we go to the solution of Y intersects Z. Remember, if it's already there, we don't put it again. Is a B already there? Yes, it is. So we don't write it again. Is a 3 already here? Yes, it is. We don't put it again. So this is my answer, how it is, which is a set containing the elements A, B, 1, 2, 3. This is number 19. Like I said, guys, it's already 12, but I'm going to continue. I think we have like about 5 or 6 more slides to go. 60 people were contracted and responded to a movie survey. The following information was obtained. 6 people like comedies, dramas, and science fiction. 13 people like comedies and dramas. 10 people like comedies and science fiction. 11 people like dramas and science fiction. 26 people like comedies. 21 people like dramas. And 25 people like science fiction. So for part A, it says use a Venn diagram to illustrate the survey result. Here's my Venn diagram. Okay, there were 60 people total, right? So when you do a Venn diagram, right, we let C be the comedies, there's that one, and we're going to let D be the dramas, and let S be the science fiction, which is this one here. You always start where they all have in common. That's why it's in red here, highlighted in red. So 6 people like comedies, dramas, and science fiction. So it's going to be this area here. That's 6. Now, just go in order how it is, right? So 13 people like comedies and dramas. So comedies and dramas will be this section here. So this has to be 13. If that's 6 already, this has to be 7, right? Then 10 people like comedies and science fiction. So comedies and science fiction will be this area here. Has to be 10. So we already have 6. This has to be 4 then, right? And then 11 people like 11 people like dramas and science fiction. So dramas and science fiction will be this area here, right? This is dramas and science fiction. So here's where they intersect. We already got 6, so this has to be 5. Now we go to comedies, right? Comedies, there were 12 people. So all this must equal to 26. We got 4 and 6 is 10, plus 7 is 17. So the answer will be 9. Because all this must equal to 26. All the comedies. Now, 21 people like dramas. So all these areas has to be dramas. We have 11 and 7 is 18. So this has to be 3. Right? Because it has to add up to 21. And finally, science fiction is 25, right? So science fiction is all this area here. We already got 10. We already got 15. So the answer will be 10. So that's the answer for A. Now for part B. How many people surveyed like comedies but neither drama nor science fiction? So we go to comedies. Right, so how many people surveyed like comedies but not dramas? So I mean it's only going to be 9 because not these right here. Only comedies by itself. Let's see here. What am I doing there? Let's see. The answer is supposed to be 9 here, guys. You see it's 9. There it is. Okay, I forgot to put what was in the outside. That's why this, right? What was in the outside was you can add all these and subtract them from 60. That's why x equals to 16. I forgot to finish that on the Venn diagram. But for the B part, the answer is 9. There's only this part here. Now for part C, how many people surveyed like dramas and science fiction, but not comedies? So let's go to dramas and science fiction. So it'll be dramas and science fiction here. Let me see here. Dramas and science fiction, right? So it's going to be only 3 plus 5 plus 10, right? Only these part here, right? Because not comedies. It says, how many people surveyed like dramas and science fiction, but not comedies? So not these right here, right? Not these right here. These are the comedies. So it's going to be only 10, 5, and 3, which is 18. How many people like none of the movies? So the answer will be none of the movies will be the number that's in the outside, which will be 16. That's how we do these type of problems. Okay. Now comes probabilities. A single playing card is drawn at random from an ordinary 52 card deck. Find the probability of drawing a queen. So here, guys, we know that that there's going to be 13 clubs, 13 of each suit, 13 spades, 13 hearts, and 13 diamonds. We know there's 26 black. There's 52 total, right? But 26 are black, 26 are red. And also there's 3 face cards for each suit, right? The face cards means that they have a face, jack, queen, and king. And there's also, right, so there's going to be 52 cards total. So for A part, for it to be a queen, is going to be 4, right? Because there's 4 queens. There's a queen for each suit. There's a queen for the diamonds, a queen for the hearts, a queen for the spades, a queen for the clubs. So it's going to be 4. Right, so it's going to be 4 queens over 52. The answer will be 1 over 13. Now for B part, for it to be a diamond, right, there's going to be 13 diamonds. So 13 over 52. The answer will be 1/4. A red card. A red card means any card that's red, which will be 26 over 52. The answer will be 1/2. And last, right, a face card or an ace. So how many face cards are there? There's 3 for each suit, so it's going to be 12, right? How many aces? There's also one ace for each suit. It's going to be 4. So 12 plus 4 over 52. Would you give us 16 over 52? Reduce it. The answer should be 4 over 13. So these are how you do these type of problems. Okay. And again, the formula for probability is a probability of the event over the number of the event over the number of the sample space. That's the formula that we use. 21. Hopefully we can be done in 4 more minutes by 12:10. Suppose 2 fair dice are rolled. Find each of the given probabilities. Okay. So for part A, right? This we're gonna use this formula here. Okay, so let's use hold on guys, let's open the door. I'm doing a workshop. Yeah, we'll come back in 10 minutes. Sorry guys, I had a student in my office. Okay guys, the first it goes here. We're gonna let A represent the event that the first die shows a 2, which would be this event here. And event B, that the sum is 6 or 7. All these, right? I mean, diagonal is 6, and these are 7. So event A is in red, and event B is in blue. So we notice, right? There's the sample space is 36. Event A is 6 because there's 1, 2, 3, 4, 5, 6. And event blue is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 with a 6th one. So it's going to be 11 here, right? So now the probability of A union B is going to be 6 over 36 for event A plus 11 over 36 for event B. And then for this means where they intersect, right? So they intersect here. It's going to be 1, 2. This is going to be 2. So it's going to be minus 2 over 36. So my solution will be 15 over 36 minus, it'll be 17 minus 2 will be 15 over 36. We simplify, will be 5 over 12. For the second part, the sum is 11, or the second die shows a 5. So for part B, right? So we're going to let A, again, this is my sample space, so we're going to let event A be my, the sum is 11. So how many are 11 will just be these 2 here, will be 2, right? So then event B, the second die is a 5, shows a 5, right? So the second die are these right here, right? These are my second die shows a 5. So it's going to be 6, 1, 2, 3, 4, 5, 6. And then for the intersect will just be 1. So let's put into the formula. So it's going to be 2 over 36 for event A plus 6 over 36 for event B minus 1 over 36 for the intersection of A and B. There'll be 8 minus 1, it'll be 7. So my answer will be 7 over 36. Okay. Now, 22. For many years, the state of California used 3 letters followed by 3 digits on its automobile license plates. So there's 26 letters in the alphabet and 10 digits that make all numbers. So how many different license plates are possible with this arrangement? These are my letters and these are my digits. So here, guys, there's no restriction. So 26 letters can go on every, right, on every blank there. So it'll be 26 times 26 and 26, and same thing with the digits because there's no restriction. 10 can go in every slot. After you multiply it out, this is the result, 17,576,000. Now what happens on this situation? When the state ran out of new numbers, the order was reversed. 3 digits followed by 3 letters. So now this becomes my digits followed by 3 letters. Eventually, we're going to get the same answer because there's still no restriction. All they did was switch the letters with the digits. And there'll be 26, 26, and 26. So we get the same result. Now for part C, right? Let's see what happens now. Several years ago, the numbers described in part B were also used up. Then the state issued plates with 1 letter followed by 3 digits and then 3 letters. So this is my 1 letter followed by 3 digits followed by 3 letters. So it's going to be 26, right? And then 10 for each one. and then 26 for each dot there. You multiply them out, and the result will be 456,976,000. That's how much it increased by just adding one more letter. Isn't it amazing, guys? It went from 17 million something to 456 million. Now comes the last part of the PowerPoint here. These are permutations and combinations. The difference between these two are the key words that they give you, or the clue words. If it's permutation, it means arrangement, schedule, or order, and the order matters. For combination, it's group, committee, set, sample, and order does not matter. So here we go. A lottery game requires that you pick six different numbers. I forgot to put the word numbers, from 1 to 99. If you pick all 6 winning numbers, you will win $4 million. How many ways are there to choose 6 numbers if the order is not important? So for part A, right, we're going to use, it's not important, so we're going to use combination. So it's going to be 99 combination 6. And this is a formula, right, for combination. So it's going to be 99 factorial over 6 factorial divided by, 6 factorial times 99 minus 6 factorial. So this is my result. You can plug that in the calculator to make it easier. So anyway, this is my result. It's going to be 1,120,529,256. For part B, it says order matters, so it's going to be permutation. That's your formula for the permutation, right? We follow that formula. And the answer will be 806,781,064,320. When it's permutation, because order matter, it's a lot more than the combination. Now I believe this is the last problem here. And exercise 59, you pick 5 out of 6 numbers correctly, you win 5,000. In how many ways can you pick exactly 5 of the winning 6 of the 6 winning numbers without regard to order? So it's going to be a combination. Okay, so 5 out of 6 numbers will be 6 combination 5, right? But remember, for the lottery, we need to pick 6 numbers from 99. So one out of the 93 losing numbers, right? Because we already got it's 6 numbers. So this is the winning number, and this is from the losing numbers. These have to add up to 6. These have to add up to 99 from the previous slide. So we're going to multiply times 93 combination 1 over, right? Remember, these has to be 99. This has to be 6. It's going to be 6. 6 combination 5 will give us 6. 93 combination 1 will give us 93. So that's my result, 558. Okay. Okay, now this is the last problem here. This is going to be combination. A financial advisor offers 8 mutual funds in high risk category, 7 in moderate risk category, and 10 in low risk category. An investor decides to invest 3 high risk funds, 4 moderate risk funds, and 3 low risk funds. How many ways can the investor do this? Here we go. Okay, guys. So this is 8 mutual funds, right? In high risk category. So from the 8, we want to invest with 3. So it's going to be 8 combination 3. From the moderate risk, right, we have 7. We want to invest in 4. So it's going to be 7 combination 4. And for the low risk, there's 10, right? And we want to invest 3. So it'll be 10 combination 3. You multiply them out, right? So we're going to get 8 combination 3 will give us 56. 7 combination 4 will give us 35. And 10 combination 3 will give us 120. So we multiply them out. And that's my result, 235,200. And I believe this was the last problem on this review. Hey guys, thank you for staying this late, and I apologize for going over, but I feel it was important to actually finish the whole PowerPoint. Thank you again for staying, and I hope this was very useful, and you can go back and view it at your own time, so you can have an idea of what will be on your exam. Thank you.
Thank you, Mr. Azasi. So, as Mr. Azasi said, this is the last Happy Math Hour for this semester. However, we will be back in the summer, so no worries. You can always join us then. So there's one last TDE for today, and it is in the same link. It'll be summer camps for kids and library resources if you can join us. We hope you all have a wonderful weekend and good luck on your exams. Thank you.
Bye bye.